I don't really need to rehearse the statistics relating to the need for carbon reduction in construction, but briefly, it is worth looking at some of the likely costs. Next, please. Next slide. That's my office. Next slide, please. Yeah. There are 29 million homes in the UK, and 2,372,777 of them are in Scotland. Homes are responsible for 20% of the total national emissions. The Times newspaper recently noted that £33 billion will be required by 2045 to convert the nation's building stock to zero carbon. I don't know how they calculated that, but I think it could be very seriously underestimated. The Climate Change Committee calculates that the cost of going to net zero will be 50 billion a year from 2030 till 2050, totaling 1,000 billion. Whereas the National Grid has come up with 4 different scenarios which might be achieved by 2050, each costing 3 trillion, suggesting to my mind that nobody's really got a grip on this. The Treasury hasn't published its own assessment, although it was due in March this year. And we do know that the expense is going to be mind-blowing, and alternatives to what we do and how we can manage our homes to achieve an acceptable target must be looked at hard. The average cost, the average current cost, next slide please, of insulating an next slide please, of insulating the existing building and changing its heating to an air source heat pump will be in the region of £20,000 to the owner, of which the Renewable Heat Initiative in Scotland, offered by the government, will contribute about £1,000 for the first 7 years, leaving a huge cost for the individual homeowner to put down up front. In other words, he's got to pay £19,000 up front, which many people cannot afford. Well, typically, our practice clients are mainly domestic, although not exclusively. Homes are responsible for 20% of the UK emissions. Our clients may require a new house on a greenfield site or want to upgrade an existing one. The greenest one, of course, is the one that is already there. Right, I'm going to show you a few slides of just some of our new build. Next slide, please. Something missed there. Next slide, please. Next. Thank you. Next. Basically, with a new build, we know what to do. It's not that difficult. You have to insulate it well, make it as airtight as possible, and try and introduce a proper managing system so that you don't heat areas that don't need to be heated. And the other thing is to discuss with the client how big their house really needs to be. This can be a difficult argument with some wealthy clients, but it could be considered really quite greedy to build a house which is bigger for an ordinary family than 150 square meters. And it's actually quite possible to live comfortably in something much smaller, which of course reduces the embodied energy in the construction of the house as well as the heat load. Politically, there may be difficulties in legislating a maximum size of dwelling. In the 19th century, tenements were often overcrowded, and the flat sizes varied from a one-room single end, which was an overcrowded 30 square meters for a poor family, to around 150 square meters or more, with high ceilings and a considerable volume to heat. Let's have a look at some other slides. Please, next. Next, please. Yeah, I mean, we have to deal with 19% of the Scottish housing makeup, which was built before 1919. And they are have lots of different problems and work in a different way from modern building. Talking about the size of them, the average size of new houses in the UK is actually getting smaller. The Building Bulletin currently calculates that house sizes since the war peaked in the 1970s and now at around 85 square meters, excluding circulation, and are currently down to about 70 square meters, excluding circulation. So that might be all good news, but a lot depends on how they're designed, and private new builds can be considerably more. Our clients often want as large as, or usually want as large a building as they can afford. And our task is then to persuade them to keep it within limits and to make it as airtight as we can, incorporate a heat recovery system, and insulate it really well, ideally with some form of natural insulation. It'll then require very little heating at all. The construction materials, of course, contribute to the embodied energy, and we will use usually timber frame, using local timber where possible, local stone cladding, and keep the level of embodied energy and carbon use as low as possible. But with a prediction of, with an existing building, pre-1919 building, of which there are 455,000 in Scotland, behaving in a different way, as I've said, the greenest building that is ready there. They're usually built in stone with a lath and plaster lining internally and no other insulation to the external walls. Next slide, please. Glasgow is full of these wonderful stone buildings. Next slide, please. Next slide, please. This is where I live, Walmer Crescent, built by Alexander Thompson. The roof may be insulated, and as long as we can get adequate insulation to the underside of the slates, this can be substantially increased. The ground floor also can be insulated, although it may have to be dug out. The problem comes with the external walls and the additional rainfall. The climate emergency has seen something like 20% increased rainfall in Scotland over the last 30 years. Although Scotland isn't as cold as Scandinavia, we have a very high sequence of freeze and thaw cycles, which can erode masonry. When insulating stone walls, the gap between the lath and plaster and the back of the stone needs to be ventilated to allow any moisture there to be carried away and to prevent the ends of the joists rotting. And the additional rainfall now experiencing can result that the inside face of that stonework that you're looking at can be permanently wet. So that means the ventilation is very important, and just banging insulation up against it is going to give you problems. You could, of course, insulate the building externally, but that will affect the appearance of traditional buildings substantially. The natural stone is attractive. Traditional architectural features such as cornices, lintels, and sills are lost. But adding insulation to the inside of the building is going to affect other details. Next slide, please. Here's a way of adding insulation which isn't a good idea. It shows the blue arrows. They show where air can come in from the outside and miss the ventilation, miss the insulation. The next slide, please. Here is the proper way to do it, but it all needs care and it is expensive. Air source heat pumps cost at least £7,000, and some dwellings will require two, which mean that upping the power supply to two-phase at further cost. And a ground source heat pump, if there is space available, can cost 3 times as much. The Edwardian architect, Sir Edwin Lutyens, was asked what his design method was. And he replied that, I asked the client how much money he has, and then I arranged to spend it. Well, the problem the point here is that architects are limited by their clients' budget in the private sector. Our clients generally know about the climate emergency and may well wish to address this as far as they can, while at the same time creating a comfortable and affordable home, and efficient home. Their budget is often unable to accommodate a zero carbon heating regime. Our answer is to reduce the heat load as far as possible, to take advantage of what government grants and incentives may be available, to use local materials and labor, to reduce the embodied energy, and to carefully phase the work to allow the ideal zero carbon solution to eventually take place. The other thing that I think we need to think about is what our expectations are in terms of heating standards. Nowadays, most people expect to be able to heat their entire home to at least 21 degrees centigrade. But it's not so long ago that central heating wasn't available. I was brought up in a house without central heating, and only a portion of one room in my house was heated to anything near this level. I don't deny that there's fuel poverty and that some people suffer from this, but it's important to have a realistic expectation that those who can afford heating should better control how much they use and where and when they heat their homes, so that management and control of heating is also an important part of our design input. Finally, to sum up, next slide, please. Well, these are cornices that obviously are a problem if you're insulating internally. Next slide, please. Yeah, so a new build, keep the size of the design as small as you can, make it airtight or nearly, insulate it well with local materials, and introduce a building management system to control the heating. And if it's an existing building, make it near airtight as possible, insulate carefully, use local natural materials, include a building management system, and consider phasing the renovation to manage the costs. I am really worried about how we are actually going to achieve what is being planned in terms of the total cost to the UK and other countries.